prepared by the generation planning section based on that national power and energy demand forecast. So normally we are studying 10 years. We are doing this system studies for 10 years. So they are normally preparing for up to 2021, but we are taking only up to 2016. So these are the new proposals for the generation. Here you can see that developing a power plant without steam turbine. And there are several 200 megawatt medium diesel power plant, and this is the Kerala power plant with the steam turbine, and again the gas turbines in 2011, and this is the Upper Kotmale power plant, and Uttaram coal power, Trimbo coal power, again Uttaram coal power, Trimbo coal power, and again the Trimbo coal power. So when we do the transmission planning, we have some planning criteria that we should satisfy. So first one is the voltage criteria. So that means if you consider this 220 kV transmission voltage, the voltage of all the 220 kV buses should be within plus or minus 5% in normal operating condition and minus 10 to 5% in single contingency condition. I will explain that what is single contingency condition. That is that we are doing the transmission studies consider that without one element, that one transmission equipment, that may be a transmission line or the transformer. So in that situation, the voltages should be around that limitation, like that. For the 132 kV, it is plus or minus 10%. For the single contingency case also, it is plus or minus 10%. So, any questions up there? Thermal criteria. And the second criteria is the thermal criteria. That means that we are looking that if you consider that transmission equipment, their transmission line and transmission transformer. So they have some thermal limitation. It can transfer power up to this much, the maximum capacity in megawatt or MP. So we can't exceed that amount. If it is exceed, we have to give the new transmission proposals to avoid, to mitigate that overloadings. Normally we allow up to 120% overloading. Above that we have to give the proposals to mitigate that transmission thermal overloading problems. Security criteria. Security criteria means that the performance of the transmission system under contingency situation. So contingency means that, as I described earlier, it is the single contingency or double contingency. So single contingency is N-1, that is we consider only out of service of only one element of transmission network. In N-2 we consider 2, but in Sri Lanka we are not studying N-2 contingency situation because it is very costly. So we are considering only N-2. short circuit criteria. So, if you have visited to any reserve station, you may see that every equipment in the reserve station has the maximum the short circuit capacity levels. So these are the typical short circuit capacity level in Sri Lanka system. So 132 and above, if it is overhead line or overhead one, that is 14 kA. That for the 33, 13.1 rated. So that means that equipment can handle only up to that maximum short circuit level. So we have to check whether our reserve station whether exceeding that maximum level or not. For that we impose that three-phase short circuit for every bus bar and calculate the maximum three-phase current of the each and every bus bar. That is every 132, 33 and 11 kV bus bars, and check whether that limit is exceeding or not. If it is exceeding, consider that 33 overhead reserve station has 30.1 kA maximum short circuit level, but if it is exceeding at the 33 reserve station level, then all the downstream equipment have to replace. Otherwise, they get damaged in a fault. So it is not possible to replace all the downstream equipment. So we have to plan our transmission network to avoid exceeding that maximum three-phase short circuit level. Stability criteria. What is power system stability? Power system stability is that ability to stay stable in normal operation or the at the failure fault without power system stability is that remaining state of operating equilibrium under normal operating condition and to regain acceptable state of equilibrium after being subjected to a disturbance. That means that after the disturbance or in the normal operation, that system should be in stable position. So that power system stability can be discussed in two forms, that is rotor angle stability and the voltage stability. Under rotor angle stability, rotor angle means that ability to interconnect synchronous machine of the power system to remain in synchronism. And that small signal stability means that the ability of the power system to maintain synchronism under small disturbance. Normally, that our software doesn't facilitate that type of stability study. It does on the transient stability. So transient stability means that the ability of the power system to maintain synchronism when subject to the severe, that is a large disturbance. And the voltage stability. The voltage stability is the ability of the power system to maintain steady acceptable voltage at all the buses in the system under normal operating condition and after being subjected to the disturbance. So, under stability criteria, we should ensure our system is stable